Adrien Bilal.
Thanks a lot, Fabian, and to Claire for organizing the paper and putting my paper on the program. So it's the geography of unemployment. Well, in fact, one second, I think now this is better. Okay, so the starting point of this paper is that unemployment rates differ dramatically between cities. And for instance, in 2017, the unemployment rate in Versailles was about 5%, which is quite low when you compare it to the southern city of Marseille, where the unemployment rate was well over 12%. Now, these unemployment rate gaps between cities are in fact not special to 2017. In fact, they are highly persistent over time. And they're also not special to France because similar gaps have been documented also in the United States, and you can think of Boston versus Flint, for instance. Now, these unemployment rate gaps are somewhat puzzling because in principle, both workers and employers could reallocate across space. And they may have important welfare consequences. We know from a large body of work that being exposed to unemployment, even in a strong labor market like Versailles, is harmful for workers, but spending a lifetime in a distressed labor market like Marseille or Flint may have dire long-run consequences. And policymakers seem concerned about spatial unemployment gaps because we see local governments spending billions of dollars every year to attract jobs. At the same time, you know relatively little about the determinants of spatial unemployment gaps. And so in this paper, I tackle three questions. First, why do we see large unemployment differences persist across locations? Second, what are the welfare implications of this dispersion? And third, in general equilibrium, then, what can we say about place-based policies that target high unemployment areas? And I propose answers to these questions in this paper in 4 parts, to which I turn now. First, I document that the unemployment rate is high in Marseille in France or Flint in the US, not because workers struggle to find jobs in these cities, but instead because workers repeatedly lose their jobs there. And even for similar workers in similar industries, differences in the rate of job loss account for 86% of observed gaps in unemployment rates. And so this key role of job loss, even for similar workers, indicates that there are systematic differences in the types of jobs offered by employers across cities, rather than differences simply in the number of jobs. And so in the second part of the paper, I propose an alternative view of spatial unemployment differences. And in particular, I build a framework that emphasizes the key role of employer heterogeneity across space. Different employers offer different types of jobs, and as they self-select across space, endogenous differences in the rate of job loss arise. But one key implication of this framework, which will become clear once we see the details, is that labor market frictions distort the location decision of jobs. And in particular, too many of the highly productive employers with stable jobs locate in top labor markets, like Versailles in France or Boston in the US, leaving only employers that are not productive enough with jobs that are too unstable in distressed labor markets. And the immediate policy implication is that place-based policies that target high unemployment areas and relocate marginally more productive jobs, more stable jobs there, raise aggregate welfare. And this provides a justification for commonly used place-based policies like enterprise zone programs. To then quantitatively assess to what extent the self-selection of heterogeneous employers across space accounts for observed unemployment gaps, I structurally estimate the MOL on French administrative data in the third part of the paper. The estimated MOL accounts for over 90% of observed gaps in unemployment rates, as well as for the key role of job loss in driving that variation. Now, importantly, the estimated MOL indicates that if employers made socially optimal location decisions, unemployment gaps across space would close by 80%. And this large reduction indicates first that the location decision of employers is critical in understanding unemployment gaps across space, and second, that there's potentially a lot of scope for policy intervention. And so in the fourth part of the paper, I then evaluate the impact of place-based policies with my estimated general equilibrium model. And I find that localized corporate tax breaks in distressed labor markets like Marseille, in particular corporate tax breaks, deliver sizable employment and welfare gains by relocating marginally more productive employers with more stable jobs towards these distressed labor markets. And I find that the optimal policy raises aggregate welfare by 5%, and I then contrast it with the real-world enterprise zone program in France. Okay, so the plan for the talk today will largely follow these 4 parts. Now, this paper is related to several literatures, and in particular to the literature on inflows and outflows from unemployment over the business cycle. Now, this literature has found that most of the movements in the aggregate unemployment rate are due to movements in the aggregate job finding rate. And largely for that reason, existing models of spatial unemployment have exclusively focused on spatial variation in the job finding rate to account for observed unemployment gaps across space. But instead, I showed in this paper that in the data, the key margin of variation is the job losing rate across cities, and therefore we need a different theory to think both about the data and to think about policy. So before I start with the empirical evidence, I'd like to ask if there are any questions at this point. Okay, well, let's jump right into the empirical evidence then. So for my main analysis, I'm going to use matched employer-employee data from France because of two main advantages of this data. The first one is that it covers a wide cross-section of workers, almost 1 million individuals in every year, which allows to break down the sample by city, but also by worker groups and industry. The second key advantage of this data set is that it has a long panel dimension, and so I can track workers throughout their employment histories and control for worker unobserved heterogeneity. Now, this data set has one limitation, which is that I can only distinguish between employment and non-employment, but within non-employment, I can distinguish between unemployed workers who are actively searching for a job and workers that are out of the labor force. And so to get around that difficulty, I do two things. First, I restrict attention to males aged from 30 to 52 years old who tend to have a high and stable labor force participation rate. And second, I complement the administrative data with the French labor force survey. In the labor force survey, I can distinguish between unemployment and non-participation. And so there, I compute conditional transition probabilities between employment, unemployment, and non-participation. I then use those estimated transition probabilities to infer the unemployment versus non-participation margin in the administrative data. Now, in practice, this imputation exercise has a very limited impact on the results because this group of workers has a high and stable labor force participation rate. But you can also redo all of the exercises in the labor force survey alone with the actual unemployment information, and you would find very similar results, just a bit more noisy. As a notion of a city or a local labor market, I'm going to use commuting zones, which are areas in which most people who live there also work there. And so in the rest of the talk, whenever I say city, location, local labor market, or commuting zone, these are all used interchangeably. To construct a fine-grained measure of skill in the administrative data, I use a combination of occupation and age information. And finally, for some of the validation exercises later on in the talk, I'm going to use some balance sheet data for the near universe of French businesses. Then finally, I'm also going to show you that my results hold not only in France, but also in the United States. And so for the US, I'm going to use the current population survey for a similar sample of workers. But let's start by looking at the data. So this is a map of France, broken down, mainland France, broken down into 311 commuting zones. And the different shades of blue indicate differences in average unemployment rates at the commuting zone level throughout my sample for prime age males. And you can see that there's quite a bit of dispersion ranging from 3 to 15% in terms of local unemployment rates. Now, Paris is here with a relatively high unemployment rate because the Paris commuting zone encompasses not only the inner city, which is quite wealthy, but also the neighboring suburban areas that have somewhat higher unemployment rates. The Versailles commuting zone is next to Paris and has one of the lowest unemployment rates in the country, about 5%. Marseille is down here with one of the highest unemployment rates in the country, 12%. But there's quite a bit of dispersion throughout the country, and to put that dispersion into perspective, you can compute the cross-commuting zone standard deviation of local unemployment rates, which is 2.3 percentage points. That's almost twice as the standard deviation of the aggregate unemployment rate over the business cycle. But not only is there a lot of dispersion, there's also quite a bit of persistence. And to see this, you can look at the unemployment rate in the second half of the sample here on the y-axis against the unemployment rate in the first half of the sample on the x-axis across commuting zones. You can see that the data lines up quite closely along the 45-degree line, indicating a high degree of persistence at the local level. And in fact, even at this 5-year horizon, the autocorrelation is 0.86. Now, these two facts, the dispersion and the persistence, are not new to the literature. They've been documented before, for instance, by Klein and Moretti. And so let me now turn to my main empirical exercise, which is to unpack how these differences in local unemployment rates reflect inflows into unemployment and outflows from unemployment. And to do that, it's very useful to start with a very simple and stylized accounting model that reads as follows. So we're going to think of a world with a bunch of cities C, no migration at all between cities, and a constant labor force participation rate in every city. Now, in that very stylized environment, the change in the unemployment rate in a given city between two time periods is simply inflows minus outflows, and the inflow into unemployment is the job losing rate, like separations into unemployment times the fraction of employed workers in that city. And the outflow from unemployment is simply the job finding rate times the fraction of unemployed workers in that city. Then in steady state, you can rearrange this equation to arrive at the following simple relationship between this transformation of the unemployment rate on the left-hand side, which has to be equal to the log of the job losing rate and the log of the job finding rate. And this relationship has been used extensively in the business cycle literature to unpack the role of the job losing rate and the job finding rate. And I'm going to run a similar exercise here, but instead of doing it over the cycle in the aggregate, I'm going to do it across cities. And more specifically, I'm going to do it in 3 steps. First, I'm simply going to plot each of those 2 terms on the right-hand side, the job losing rate and the job finding rate, against the left-hand side to see which one is driving most of the variation. Then I'm going to show you that my results are virtually unchanged after controlling for worker observable characteristics as well as unobservable characteristics. And then I'm going to show you that the patterns are quite similar in the US relative to France. Okay, so let's start by looking at the raw data. So here on the y-axis, you can see at the log of the job losing rate plotted against the log of this transformation of the unemployment rate on the x-axis. And you can see that the data lines up closely on the 45-degree line, indicating that differences in the rate at which workers lose their jobs across space are the key determinant of spatial unemployment gaps. And in fact, if you do the same thing with the job finding rate, you see that it's comparatively flat across cities. And in an accounting sense, the job losing rate accounts for 86% of the cross-sectional variation in unemployment rates. Now, of course, you may think that part of that dispersion or the role of job loss is driven by compositional differences across cities. Maybe workers are different or maybe industries are different. And so to account for that possibility, what you can do is project worker level job loss, job finding, and unemployment probabilities on a set of city fixed effects, 232 industry fixed effects, and 300 skill group fixed effects. Then you can retrieve the estimated city fixed effects and repeat the same exercise here in green. And you can see that the picture remains essentially unchanged. There's still a lot of dispersion in local unemployment risk, even conditional on those observables. And if anything, the variance share of the job losing rate increases to 91%. Now, you may also think that maybe part of that is driven by unobserved heterogeneity within those 300 skill groups. And what you can do in the French data to account for that possibility is strip out worker fixed effects from a similar regression. So here, because we're conditioning on worker fixed effects, the city fixed effects are identified from movers who move between cities, and we're comparing, say, their job losing rates on average before the move and after the move. And you can see that by doing that, you reach an essentially unchanged conclusion. There's still a lot of dispersion in unemployment risk, and it's primarily driven by differences in the rate at which workers lose their jobs. And quantitatively, this worker level heterogeneity accounts for about 20 to 25% of the cross-sectional dispersion. So it's not nothing, but it's far from being the main driver of differences in the rate at which workers lose their jobs. And so finally, so this is for France, and I'm going to show you that in the US, we find very similar patterns. So in the US, because of the much smaller cross-sectional size of the current population survey, you have to bin cities into 20 groups. But after you do that, you can repeat the same decomposition exercise, and you find that the job losing rate is, again, the primary determinant of spatial unemployment gaps across metropolitan areas in the United States. Okay, so just to recap, so far I've shown you that there are large and persistent differences in unemployment rates across cities, that these differences are primarily driven by the rate at which workers lose their jobs across space. And because that's the case even for similar workers, it indicates that there are systematic differences in the type of jobs offered by employers across space rather than differences in the number of jobs. And so before I turn to the second part of the paper where I build a theory of employer heterogeneity across space, I'm going to take a couple of questions if there are some.
Okay, we've got some questions, so we will, as Fabian mentioned, we'll ask them in the order that they appear on the upvote box. So there's first a question from Alessandro Di Nolo. You should be able to speak now.
Can you hear me?
Yes.
Yep.
Yeah, I was wondering how crucial is in the decomposition exercise, how crucial is the assumption of no migration of workers between cities?
I see. Yes. So that's a good question. So for the decomposition to hold exactly, it's important. Now, if you had, let me go back here. If you had migration between cities, that would simply introduce a structural residual in that equation. And so by staring at these two pictures, you can immediately see that the structural residual is in fact not very important, because you get most of the variation here already along the 45 degree line. It's the same thing for, say, movements in and out of the labor force. They would also induce a structural residual in this decomposition exercise. And so that it's also, you can account for it by explicitly writing down a three-state model with movements in and out of the labor force as well as with migration. And you can then quantify the role of the structural residual, and it's not going to exceed more than 1 or 2% of the overall variance in unemployment rates.
Okay, thanks a lot.
We've got another question here from Tommaso Puzio, so you should now be able to speak. A little delay on the unmute functionality. Here we go.
Well, do we have Tommaso with us?
We do. There's something.
Oh, sorry. I didn't press unmute myself. I'm so sorry.
Okay,
So I repeat the question. Can you hear me now?
Yes.
Yes.
Okay, great. Hello, Adrien. Tommaso
Hello.
here. So the question is essentially whether the J to J rate is higher or lower in high unemployment area.
Yes.
The reason why I'm asking this question is because essentially, you know, the distinction between job losing and job finding is actually somehow, you know, not obvious, right? It can be that maybe someone is actually losing the job, but then finding immediately another job, and so it doesn't show up as a losing, right? Anyway.
Yeah, absolutely. So you can look at the J to J rate in the data. So that's the green bubbles here, and you can see that, you know, so it's a little bit more. There's a little bit more of residual dispersion. If anything, there seems to be a little bit of a relationship with city size, but there's not a very strong association with the local unemployment rate. And so the job to job mobility rate, to a first approximation here, seems fairly constant across cities once you rank them by their local unemployment rate. And so this also tells us that you know, it's meaningful to look at the job losing rate because, you know, both the finding rate and the J to J rate are flat across cities when ranked by their unemployment rate.
Right, we're going to ask one more question in this batch, so we don't interrupt your flow too much. We will keep the rest of the questions active, so they can either be asked at a next pause or at the end of the talk. So next is Andrew Garin, who's now unmuted.
Hi, yeah, this is super interesting. So I can you hear me?
Yep.
So, you know, one thing that was very striking about the map you showed is that unemployment rates were so much higher in kind of in the South Coast. And having been in the wintertime to some towns there that entirely shut down, you know, I noticed you have a seasonality tab as one of your links. And I was just wondering if you could kind of talk through that, how we should think about seasonality and towns that essentially like shut down for the winter in the context of your measurement.
Absolutely. Yeah, so that's one thing, you know, as you mentioned in the map, you can see that there's more employment in the south. So we wonder maybe, you know, that's tourism activity. So you can look at seasonality and you can break down those spells of job, these job losing rate probabilities by quarter, for instance. And essentially you do see that, and then look at seasonality across the distribution of cities when you rank them again by their local unemployment rate. And so you do see a little bit more of seasonalities in structurally high unemployment cities. So, you know, and that's coming partly from these cities in the south. Which you can see from the fact that these, you know, the line is changing slope in the third quarter, so this in the summer quarter. So you're exactly right that seasonality seems to matter a little bit, but quantitatively it's very small. It would, you know, if you attributed all of these persistent unemployment gaps purely to seasonality, that you would be able to explain only 6% of the cross-sectional variation in unemployment rates. So there's something about, you know, jobs being structurally more unstable in these areas that cannot be explained by seasonality alone.
Thanks.
Great. All right. So let me now move on to the second part of the paper, in which I build a framework to think about these differences in job losing rates across space. And so that's going to be a theory that emphasizes the role of employer heterogeneity across cities. So let me start by describing the main ingredients of the model. So we're going to have many cities, and then within every city, there's a frictional labor market in which workers find jobs, lose jobs, and are unemployed part of the time. So that part of the model will look a lot like Klein-Moretti's spatial unemployment model, but we're going to add a key building block to that environment, which is a location decision for heterogeneous employers. So employers are going to be inherently different. Some of them will be highly productive and offer high productivity jobs, while others will be less productive and offer low productivity jobs. You can think of a low productivity job as a burger flipping position at McDonald's, while a high productivity job would be a meat specialist position at a high-end restaurant. Now, of course, all jobs are subject to some idiosyncratic fluctuations. Sometimes workers fight with their manager and get fired. So all jobs will eventually terminate, but jobs at more productive employers like the high-end restaurant will be endogenously more stable. And then because these employers have a location decision and choose where to go, they'll sort across cities for reasons that will become clear in a couple slides. And so this sorting will then, through the connection between productivity and this job stability, will lead to endogenous differences in the rate of job loss. So I'm going to start with a kind of a bare bones economy that only has the key ingredients to make these mechanisms precise. And then before we turn to the data and the structural estimation, we'll add some bells and whistles to that economy. Okay, so time and space are both continuous, and the continuum of city sites is indexed by the local TFP of the city on that continuum. That has some exogenous distribution in the economy. So for the main mechanism I'm going to discuss today, this local TFP is useful mainly to index and rank locations, but you can think of these differences as being very small if you like. And you can also think of them as reflecting in part the average human capital of the workers who are living in that city. And later on in the quantitative part, we'll make these differences endogenous through human capital differences of workers. But for now, let's just think of them as being exogenously fixed and very small if you like. Then in every city, there's a fixed supply of housing that results in some land rents that have to be paid to landlords who only consume a freely traded final good. Workers for now are all the same and live forever, and they like consuming the freely traded final good, which is our numeraire, as well as housing with the Cobb-Douglas flow utility function with the share omega on housing. And then they discount the future at rate rho. These workers can be either unemployed or employed, and for now, they're going to be freely mobile across space, so there's no restriction on worker mobility. Local labor markets are fairly standard. There's a single labor market in every city, and workers can search only where they live and during unemployment. Then unemployed workers randomly meet vacancies according to a Cobb-Douglas matching function with an elasticity alpha on the number of locally unemployed workers. Workers and employers Nash bargain over wages with a bargaining power beta for workers. And then during unemployment, workers either produce something at home or earn some unemployment benefits, which are allowed to depend on the city where they live. And to keep the exposition simple, I'm going to immediately specialize this home production to a linear function of the local TFP, which is going to be a parsimonious way to capture the idea that unemployment benefits are constant replacement rate over past wages in France, because wages will scale with local TFP. This is going to be consistent with it. It's also going to make the exposition a bit simpler, but you can have more flexible functional forms here if you like. And so far, the economy looks a lot like the Klein and Moretti spatial unemployment model. And now to this kind of first building block, we're going to add a second building block, which is a location decision for our heterogeneous employers, which will be the source of these endogenous job losing rates across space. So the first step of this location decision is that employers have to pay an entry cost to be able to operate at all. And then they learn something about how good they are. I'm going to call that quality and denote it by Z. And so this is where employers learn whether they're going to open a high-end restaurant with high productivity meat specialist position or whether they're going to open a McDonald's franchise with low productivity burger flipping positions. Okay, once they know the quality of the job they're going to open, employers decide where to go, they choose their location, and post a single vacancy in the local labor market. After a while, the vacancy may match with a worker, in which case employers will draw their match-specific productivity Y0 from a distribution that depends on their quality, which is why quality matters for expected productivity. And again, to keep the exposition simple, I'm immediately going to specialize this conditional distribution to a Pareto distribution where the tail index inversely depends on employer quality. And so here, more productive employers draw from a right-skewed distribution, and so they're more productive on average. But if you don't like the Pareto assumption, you can work with different distributional assumptions, and I discussed that in the paper. If they decide to produce together, the employer and the worker produce YT times L, where YT is the idiosyncratic productivity T units of time after the match was created, and L is the local TFP of the place. And so this technological complementarity in the production function is how these local TFP differences rank cities from the perspective of employers. The productive unit is the match. And so you should think of these employers, you can think of them in different ways. One way to think about them is firms that operate a single worker, but you can also think of them as big constant returns to scale firms that operate many matches at the same time. And so in the McDonald's case, you can think that most of the burger flipping positions are going to go where the retail restaurants are, which is mostly in Marseille, but maybe there are also going to be some high quality Z headquarters service jobs, which are going to go to Versailles. So this is really a job level model that doesn't take a particular stand on the boundaries of the firm. Okay, and then over time, the productivity of the match fluctuates, and it's going to follow a geometric Brownian motion, which is just a continuous time analog of a random walk with drift. And this productivity process is important because it's persistent, and therefore it's going to tie together the productivity of a match at a given point in time with the risk of job loss. And more productive matches will be less likely to break up because it takes more time for productivity to slowly depreciate to a low enough value for the match to separate. Of course, eventually, all matches will break up, and so we're going to get endogenous separations in this economy. And also importantly, this productivity process is the same across all locations, and so differences in the rate of job loss will have to come from something else than the productivity process itself. Okay, so we're going to solve this location decision by backward induction. We're going to start by figuring out what an employer in a given city does whenever they keep operating, whenever they lay off the worker. Once we know when they lay off workers and when they keep operating and their value, we're going to take a step back, integrate the value of an employer against the starting Pareto distribution to characterize the location choice of employers across all possible cities. But starting with the inner nest, what an employer does conditional on being in a city, L with match-specific productivity Y, we recognize that the value of that employer has to reflect several elements. The first one is the flow surplus from the job, which is simply flow output minus the worker's opportunity cost of operating in that match, which is for the foregone home production, as well as the foregone option value of searching for a different job in that city, which is here denoted by V. I've already solved out for the wage bargaining here, and so employers get a fraction 1 minus beta of that flow surplus. And then because productivity fluctuates over time, there's a continuation value that arises because of changes in future productivity. The first derivative here encodes the contribution of the negative drift in the productivity process, while the second derivative encodes the contribution of the volatility in the productivity process. Now, of course, this Bellman equation holds only when productivity is high enough and the match finds it optimal to keep operating. And in particular, it holds whenever productivity is above an endogenously determined job losing cutoff Y bar. And that cutoff is jointly determined with the value according to the value matching condition, which tells us that matches break up when there's nothing left on the table. And so the value of the cutoff has to be 0. But also according to the smooth pasting condition, which tells us that because this cutoff is chosen optimally, you get a first order optimality condition with respect to the cutoff, which tells you that the derivative of the value at the cutoff has to be 0. Now, quite conveniently here, you can in fact solve in closed form both for the value and the cutoff. And that's quite useful to then take a step back, compute the expected value of entry across all possible locations for a given employer with quality Z to characterize the location choice of these employers. And if you do that, you can boil down the location decision of a given employer Z to the following 3 terms that encode 3 forces that drive the location decision of these employers. The first term in blue simply reflects technological complementarity in production. And so it tells us that more productive, high quality employers value relatively more places that are better suited for production. And so that just reflects the complementarity in the production function. And this type of complementarity has been found in many papers in the assignment literature, and so is not particularly specific to the presence of labor market frictions. The second term in orange is specific to the presence of labor market frictions and is at the heart of the mechanism I proposed in this paper. What does this term show up? It tells us that more productive, high quality employers value relatively more places where it's easier to find workers, as measured by the vacancy contact rate. This term shows up because more productive employers generate higher profits on average, but that means that for them, waiting relatively longer until they start producing is more costly because they forego these higher profits. So in practice, they have a higher opportunity cost of time and want to go where it's easy to hire. Now in equilibrium, the vacancy contact rate depends on the tightness of the local labor market, which itself depends on the size of the pool of vacancies relative to the pool of unemployed workers in that city. And so therefore, I'm going to follow Marshall's terminology here and call this complementarity or labor market pooling complementarity. And then the third term, of course, that affects the location decision of employers is simply the expected cost of labor, which can be summarized by the reservation wage, W bar, which itself is simply proportional to the reservation cutoff. Okay, so these three forces, the two complementarities and the expected cost of labor, are going to determine the location decision of employers. And these two complementarities, technology and the pooling complementarity, will act as single crossing conditions, and so employers will sort across cities. In particular, more productive employers will prefer to go to high TFP cities or cities where it's easier to find workers, and reservation wages will sustain that assignment. Now, to understand the nature of the sorting, it's useful to go through the following mechanics of the sorting. In particular, it's useful to think through why don't the productive employers who want to hire rapidly don't go to Marseille, where you have many unemployed workers, and it would seem like it would be easy to hire there. So what's happening here in equilibrium is that in Marseille, not only is the unemployment rate high, but wages are also low there, and so cheap labor attracts many unproductive employers there, and so much that it eventually crowds the labor market, making it harder to hire in Marseille. So Marseille has a low vacancy contact rate, and so the highly productive, high quality employers with stable jobs, in fact, prefer to pay higher wages in Versailles, but locate there to be able to hire rapidly. And the flip side is that now, because you have these productive employers in Versailles that bid up the price of labor, the low productivity employers don't want to go there anymore because they don't mind waiting a bit longer to find workers, and so they go to Marseille. Okay, and so overall, the sorting of these different employers across cities will then translate into differences in the rate at which workers lose jobs, and will allow them all to match the differences in job losing rates across space. But now, why would this model also predict relatively flatter job finding rates? To understand that, it's useful to turn to the location choice of workers. So location choice of workers is a bit simpler because they're all the same, and so we only have a free mobility condition that equalizes the value of unemployment across space. In that world, you can show that the value of unemployment is simply equal to the reservation wage adjusted by the local price of housing. And importantly, reservation wages reflect two things here. First, the equilibrium quality of employers who locate in that given city, because these better employers will pay actual wages once the unemployed worker actually gets a job. But then, of course, reservation wages reflect the job finding rate, which is just how likely the worker thinks they're going to get a job. And here, importantly, we see that having housing in the mall is critical for its ability to match a flat job finding rate in the data. Why is that the case? Because if you take out housing, then the free mobility condition equalizes reservation wages across cities. Now, given the sorting of employers across space, that would imply that to make workers indifferent across space, you would need big differences in job finding rates to offset that, which we don't see that in the data. And so here it's important to have housing to provide an extra margin of adjustment to compensate workers across cities and have both big differences in actual wages across space with flat finding rates. Now, of course, this is just a possibility result. Why would we expect the mall to actually generate flat finding rates? Well, that's because the job finding rate in this economy is the product of two forces that will offset each other. The first one is simply the rate at which workers contact employers, which depends on the tightness of the local labor market. But now, because these employers draw a match-specific productivity upon meeting the worker, there's an extra term, which is the conditional success probability that a given contact results in a viable job. And these two forces move against each other in equilibrium. Why is that the case? Well, remember that employers like to go, high-quality employers with stable jobs like to go to places that have high vacancy contact rates, like Versailles, which means that in Versailles, workers are not meeting a lot of employers. So the contact rate is low, but conditional on meeting an employer, that employer is high quality and makes a highly viable job offer. And so on average, the conditional success probability of a given match is higher in Versailles. Whereas in Marseille, workers contact a lot of employers, But conditional on meeting an employer, these employers are not very productive. And so many of those meetings result in a dead end. And so this conditional success probability of a given contact pushes back against differences in contact rates, resulting in potentially flatter finding rates across space. And in a couple slides, I'll show you some data on the contact rate versus the success probability that lines up with the implications of this theory. But before we do that, let me give you a more precise characterization of the sorting patterns in equilibrium. So under some conditions that I discuss and extend in the paper, you can show that there exists a unique steady state, and that in the steady state, there is positive assortative matching, meaning that high quality employers go to cities that have higher TFP, and reservation wages are rising in the background to sustain that assignment. Now, of course, in the background here, the tightness of the local labor market and the vacancy contact rate are also adjusting an equilibrium. And so to isolate the contribution of the labor market complementarity here, it's useful to consider the following limiting economy in which these exogenous TFP differences across cities disappear and all these L's converge to one. So in that world, locations are ex ante the same, but you can still show that exposed in equilibrium, they're different. In particular, they have differences in the tightness of their local labor market, differences in vacancy contact rates, and importantly, differences in the quality of employers who decide to go there. And higher quality employers go to places that have higher contact rates. And so what this limiting result is telling us is that this labor market pooling complementarity, which arises because employers are different and there are frictions in local labor markets, is strong enough to create some form of agglomeration in the labor market and make these cities look different exposed, even though they were all the same to begin with. But overall, this result is telling us that employers are sorting across cities in this economy, and because of this sorting, we're going to have differences in job stability across space. So I'm going to turn to tie back these differences in the type of employers and the quality of employers across space to differences in job losing rates across cities. And the job losing rates, which is our key empirical object of interest here, depends on three key forces. The first one is the starting productivity of newly created matches, which depends on the equilibrium quality of employers in that city. The second thing it depends upon is the endpoint of the productivity process where these matches break up. That's the reservation cutoff. And then, of course, it depends on how fast productivity depreciates from the starting point to the endpoint. And that's just governed by the negative drift of the productivity process on average. Now, to make this point precise, you have to solve for the entire distribution of employment across productivities within every city, but you can again do that in closed form, which allows you to derive a tight connection between the sorting of employers across space and the rate of job loss. And in particular, you can show that the job losing rate in a given city is simply inversely related to the location decision of employers, namely to the quality of employers in a given city. And because we know that employers sort across space, we're going to have big differences in job losing rates across cities. In Versailles, where employers are highly productive, we're going to have low rates of job loss, whereas in Marseille, where employers are not so productive, we're going to have high rates of job loss. The finding rate is the product of these two forces, the contact rate and the success probability, which when the bargaining power is not too big, you can show move in opposite directions. And then whether they close to offset each other quantitatively will be a quantitative statement later on. Finally, the unemployment rate is just a familiar expression with the job losing rate and the job finding rate that we used in the empirical section. Okay, so far I've shown you that there's sorting in this economy and showed you how the sorting translates into big differences in job losing rates and relatively flatter finding rates. Now, before we turn to the normative implications of this that arise in this environment, I'd like to show you some simple moments in the data that line up with the main predictions of the model. Before that, I'm going to take one or two questions, but not more because I'm not particularly ahead of time.
Perfect. Let's ask. We've got a couple here. So first from Cecile, should be able to speak now. From Cecile Gober.
Yes. Hi, Adrien.
Hi, Cecile.
Hi. So my question was, so I thought that your model suggested that you had to have a lot of vacancies in those high unemployment areas, like in Marseille, but very few in Versailles.
Correct.
But I would have thought, like intuitively, I would have expected the opposite, that
yes.
There were, a lot of job posting in kind of booming areas and less so in lagging areas. And so can you check that in the data? Or any?
Yes, so I'm not going to be able to look at vacancies directly. I'm now in the process of applying to vacancy data in France to check that directly. So the first thing is, if you had a lot of vacancies in booming areas, you should see big differences in job finding rates, which we don't see in the data. So it has to be the case that to have the flat job finding rate, it can be that vacancies vary too much across cities in the way you just described. Now the model here, this simple model predicts that you have, in fact, a bit more vacancies in Marseille, but so that would implies a higher contact rate, but this higher contact rate is offset by lower success probability of a given contact. I'm gonna, in 2 slides, I'm gonna show you data on exactly that. So we can discuss again in the Q&A if you feel that the data exercise there convinced you of that fact in the data or not.
Great, we've got a couple more with a lot of upvotes, if that's all right, Adrien, and we can eat into the Q&A at the end.
Okay, yeah, I'm gonna move to the data. So in the process, I'll also answer Cecile's question.
Okay, do you want to just take 1 or 2 more now then?
Okay, one more now. Yes.
1 more. Okay, we've got Sharon Trademan. You should be able to speak now.
Hi, Sharon.
Yeah, I guess just could you say a few words for those of us not from France, just about the role that the public sector might have in some of this variation in just unemployment rates and separation rates across space? Like, I wonder if they're a big absorber. They're a big absorber.
So yes. So I haven't checked explicitly whether there were big differences in jobs at the public sector or not. I would expect jobs in the public sector to be more stable because there's just more restrictions on firing in the public sector than in the private sector. Now, remember from the exercises I've shown you earlier, I was accounting for industry fixed effects in the exercise, and you could see that it barely essentially didn't change the empirical results, which mean, and these industry fixed effects, in fact, directly control for public sector versus private sector, in fact, at a much more disaggregated level than that. And so that's already telling us that it's not going to be a big, cross-city variation in the public sector employment is not going to be, cannot be a big explanation for why we see these unemployment gaps across space. All right. Okay, so let me now, in fact, turn back to the data and show you some simple moments that line up with the, that line up with the main mechanisms in the model. And so one, key connection in the model is this connection between labor productivity and the probability of job loss. And so in cities that are more productive, where labor productivity is higher, we have lower rates of job loss. And so if the rate of job loss is high, then we should see lower labor productivity. That should be true on average, but also in a distributional sense. That is, in Versailles, you should see the entire distribution of labor productivity being shifted to the right. And so using balance sheet data for the near universe of French businesses, you can test these 2 implications. So here on the x-axis, I'm showing you the log of labor productivity and for different groups of cities. In blue, we have the cities like Versailles that have low job losing rates. And in orange, we have cities like Marseille that have high job losing rates. The vertical bars here are the group means, and you can see that in cities like Versailles, labor productivity is typically 50% higher than in cities like Marseille, which is consistent with this first implication of the theory. Now you can compute the cumulative distribution of labor productivity within each of those city groups, and you can see that, in fact, in Versailles, the entire distribution of labor productivity is shifted to the right, consistent with this second implication of the theory. And in the paper, I have a number of additional exercises that show that the productivity process seems to be fairly consistent across cities, as well as showing that these gaps are much bigger for young firms than older firms. I just have to plug in my computer. Okay, so overall, these moments indicate that there's a tight connection in the data, as in the model, between the productivity of a given match and the probability of job loss. Okay, so turning to the flatter job finding rate and Cecile's question, you can also use the labor force survey in France to unpack how job finding rates reflect contact rates of workers across different cities and this conditional success probability of a given contact. In fact, using information in the labor force survey that tells you the duration since workers received their last job offer and comparing that to the duration of unemployment, you can show you can show that the contact rate in Marseille, so in the structurally high unemployment cities here on the right of the graph, seems to be higher, whereas the contact rate in low unemployment cities like Versailles to the left of this graph is lower. And so that's telling us that in Marseille, workers are contacting employers more frequently, but conditional on contacting an employer, they're less likely to accept the job offer. Whereas in Versailles, workers are not contacting a lot of employers, but conditional on contacting an employer, they're more likely to take the job, which explains the difference between the slope in the job finding rate and the contact rate, which are moving in opposite directions. And so that again is telling us that it can be that, going back to Cecile's question, that there are a lot more vacancies in Versailles relative to Marseille. If anything, the data suggests the opposite, which is also an implication of the model. Okay, so having shown you some basic moments that line up with the predictions of the theory, let me now turn to the normative implications. So just like in any search model, you should expect at least the standard congestion and separation externalities to operate here. And so the overall entry margin and the separation decision can be efficient only if the Hosius condition holds, namely if the bargaining power is equal to the matching functional elasticity. But here, because geography creates many labor markets and employers are different and choose from these many labor markets, there's an additional source of externality, which I call a labor market pooling externality, because it's tightly connected to the pooling complementarity that we've discussed before. And to understand the nature of this externality, it's useful to consider a mom and pop restaurant. So you can think of it as an intermediate productivity firm that's choosing between going to Marseille, where there's mostly low productivity burger flipping positions, and Versailles, where you have high-end restaurants. And this stylized representation of the world, if the intermediate productivity restaurant goes to Versailles, it's going to be less productive than the average incumbent there. But because it gets pooled in the same labor market as the otherwise more productive incumbent, it still gets to contact as many workers as these other better firms there. And so that means that this intermediate productivity firm always has an incentive to try to free ride the next best labor market, because wages don't fully price this congestion effect, this compositional congestion effect. And because that extra incentive to free ride the next best city arises everywhere in the geography of this economy, on net, in equilibrium, you end up with excess concentration of the good jobs in Versailles and not, and jobs that are too unstable and not productive enough in Marseille. So you can make this argument precise by writing down a planning problem, and you can show that the decentralized equilibrium is always inefficient in this economy, regardless of whether the Hosius condition holds or not. Now, the question is whether policy can do something about that or not. And you can show that you can restore efficiency in this economy with a set of place-based policies. And these place-based policies take the form of profit subsidies or corporate tax credits that are bigger in cities with high rates of job loss. And so Marseille gets a big corporate tax break, whereas Versailles doesn't get him. And so what these corporate tax breaks do is they incentivize marginally more productive employers with more stable jobs to relocate towards high unemployment labor markets, and they undo the labor market pooling externality. And so what this result is telling us is that this labor market pooling externality, whereby employers overvalue the benefits from locating in top labor markets and free ride the favorable hiring conditions there, provides a rationale for commonly used place-based policies like enterprise zone programs. And at this point, it's also useful to flag that this policy implication contrasts with what the literature on agglomeration economies typically finds. The presence of agglomeration economies would tell you that you would want to tax the low-income locations and subsidize the high-income locations. Of course, if you wanted to account for the overall net spatial policy, you would have to have both forces in your model and estimate them. But I'm not going to do that today. Today, I'm simply going to focus on this labor market pooling externality and quantify its importance in explaining observed unemployment gaps across cities, as well as the associated policy implications. I'm going to take one question now, if there are some.
Terrific. Yes, there are plenty now. So we've got Tommaso has another question. So should not be unmuted.
Yes, so thanks so much. Hi again. No, I just super interesting mechanism. But in my understanding, it seems that at the core of it is this ability of entrepreneur to choose where to locate. And so that seems extremely reasonable if it is McDonald's or Starbucks choosing where to put an establishment. But then I guess I know like in Italy, most entrepreneurs are just like, opening wherever they're born. So I was wondering whether you look at the data in France or, whether you have any evidence for this, or what are your thoughts on this in general?
Yes. No, that's a great point. I mean, we know that the majority of employment is in large firms. So in some sense, the majority of jobs are going to be in firms that, have do that arbitrage to some extent. Then you can look, so in the paper, I look in the data at firms that have multiple establishments, and you do see that a lot of the job stability, differences in job stability are firm specific. You can tease that out using the multi-establishment structure. And you do see, and then you do see that, these firms do select across space in systematic ways that align with the predictions of the model. Now that's identified only for firms that have many establishments. And so I can't, without having explicit data on where the entrepreneur is born and where they open their job, I can't directly test whether this type of firms are very sensitive or not to differences in labor market conditions across space and when they decide to open their business. If that was the, you could extend the model and add some, you could have some preference heterogeneity, maybe for employers as well as for workers. And so that would give you a less elastic location decision on the firm side as well. That would allow you to account for that particular margin that you brought up. So that makes the computation of the model a lot harder. But in principle, it's not something that would be impossible. But you would need better data than what I have currently to estimate that elasticity. Okay.
One more question with an awful lot of upvotes from.
Okay.
Come, feel free to postpone it to the end, but if you want to just take one more.
Let's do one more now, and then.
Right, then we'll postpone the rest.
We'll postpone to the end. Yes.
Hi. I was wondering how your story. Hi everybody. Hi Adrien.
Hi.
How your story interfere with standard agglomeration effects. That is, density increases productivity, so labor productivity is endogenous. So my impression that it should reinforce your mechanism. But on the other hand, my impression is also that unemployment rates are increasing with density in France. Is it true or?
Yes. So there are really two questions in one. It's a great point. So it is true that unemployment rates, increase with population density, but the correlation is not very strong. And in fact, in the extended, they increase with density, but they decrease with local wages. I mean, these are just equilibrium correlations. In the extended model that I'm going to show you later, I'm going to match these two conditional correlations. In fact, what's happening is that unconditionally they increasing in density, but once you control for enough observable characteristics, in fact, the correlation with density completely disappears. And so that's going to be something that the quantitative model is going to match. And I'm happy to discuss that further in the Q&A, because it's a little bit subtle what's going on there. And then regarding your point about agglomeration economies, so it's true that they interact, but if you added agglomeration economies, it means that the good firms go to too much to the top places. That creates too much agglomeration there, which then boosts productivity further, which attracts even more firms. So it's true that these mechanisms are self-reinforcing, because the policy implication goes in the opposite direction. In some sense, if you think that there are agglomeration economies and people don't internalize them, then this pooling externality, which goes the other way, in fact, helps agents internalize the agglomeration economy. So you could figure out some parameter configuration in which the optimal policy is then to do nothing, because these two externalities offset each other. I'm going to show you that quantitatively, it seems that the pooling externality seems to be stronger than what people traditionally estimate in terms of agglomeration economies. But I won't have anything quantitative to say about which force is exactly stronger than the other.
Adrien, we'll stop questions there because there's 15 minutes till the end, including the Q&A. Great.
Perfect. Okay. So this is a great transition into the quantitative extensions and the structural estimation of them all. So in order to be able to turn to the data, I'm going to add a number of bells and whistles to this economy in order to account for the data in a more precise way. So first, we're going to add another dimension of variation across cities, which is amenities. So now cities differ both in the local productivity P and amenities, and this will allow them all to jointly capture a variation in wages and population across space. to get a better handle on congestion effects, we're going to let housing supply respond elastically to demand with an elasticity eta. And we're going to let congestion effects also affect firms who use housing in production with a Cobb-Douglas share psi. Also to let workers reallocate in a milder way to changes in economic conditions, just like in the data, we're going to add a simple notion of migration frictions to this economy. And in particular, every once in a while, workers are allowed to move, in which case they draw Frichet distributed preference shocks for cities, which result in an effective migration elasticity 1/epsilon. And then an important extension is to let these workers be different as well. So workers will differ in their human capital at birth, but they will also accumulate and lose human capital over the life cycle as they transition between employment and unemployment. And in particular, human capital will slowly depreciate during unemployment, allowing them all to capture scarring effects from unemployment. And this will tell us that in cities with structurally high unemployment, these scarring effects will be particularly severe. And this is going to provide a potential amplification channel for the welfare gains from place-based policy. And then finally, to offset part of the strength of the externality, I'm going to let employers post many vacancies, or you can think of it as recruiting effort at a convex cost. And so this is going to allow more productive employers who want to hire more rapidly to exert more recruiting effort wherever they locate. And so it's going to undo part of this labor market pooling externality, which is really due to the randomness and the matching process. And so you can think of this a little bit as letting the data tell us where we sit between random search and directed search. Now, despite all of these extensions, in fact, the model retains much of its tractability. And so you can show in particular that employers sort along a composite index of productivity and amenities. And they still, so employers now value these differences in this index, differences in the vacancy contact rate, but also differences in the endogenous human capital of workers across cities. And because of these scarring effects that vary across cities as workers go through employment and unemployment across cities, you can show that in fact, the average human capital across cities is a decreasing function of the local unemployment rates and can be simply plugged into the location decision of employers that we had before. Now, this tractability here is useful in order to estimate the model. So there are 18 parameters and 2 distributions to estimate. 3 parameters have to be normalized, but for most of the others, you can figure out a recursive scheme that's useful to get estimating equations one after the other to identify all of the parameters and in fact provide a formal proof of identification. So there's not going to be any simulations until the very last step where we estimate the entry cost. Along the way, I'm going to recover the 2 distributions non-parametrically. Now, as much as I would love to go through the 14 estimating equations with you today, I don't have time to do that, unfortunately, so I'm just going to focus on a few key parameters. So a key step to get that recursive scheme off the ground is to start by estimating the productivity process. And so the drift and the volatility delta and sigma have implications for how fast wages grow with tenure and how fast job losing probabilities decline with job tenure. And so, in fact, you can show that the time aggregated job losing rate in the first year of a job in a given city is a simple decreasing function of the ratio between the drift and the volatility, conditional on the average job losing rate in that city, which you can directly measure in the data. And so the intuition here is simple. If the drift is very big, then workers simply lose their jobs at a constant rate over time. And so the profile is flat. Whereas if the volatility is very big, most of job loss happens early on when the productivity distribution is far from stable. Now, this S1 function is not particularly pleasant to look at, but it's explicit. And so you can directly estimate this ratio with the nonlinear least square regression. Once you've got the ratio, you can recover the common scale by looking at wage by tenure. So then you have both the drift and the volatility, and you can go back to this key equation in the model that links the job losing rate in a given city to the equilibrium quality of employers in that city. You invert that relationship to get a spatial distribution of quality across cities. And that spatial distribution then immediately identifies the quality distribution at entry. And so here it's important to keep in mind that once you've estimated that quality distribution at entry, there's in fact no guarantee that once you solve and simulate them all, you're actually going to match the spatial distribution of job losing rates and qualities across cities because there's no extra restriction that is put upon the location decision of employers. Okay, so far I've shown you how I estimated the drift, the volatility, and the job quality distribution. So there are many other parameters, and I'm happy to talk about the identification of those parameters in the Q&A or by email afterwards. I'm also going to skip the over-identification exercises in the interest of time and jump right into the results. So this shows the model solution at the estimated parameter values. So the first panel on top left shows the job losing rate across cities ranked by their local profitability index, which is this composite of productivity and amenities. And you can see that it's monotonically declining, which is consistent with the theory and reassuring. And you can also see that there's a factor 4 between the best and the worst city in the economy. The job finding rate in proportion is comparatively flat across space, which is why the unemployment rate largely tracks the declining pattern in the job losing rate. So at least qualitatively, the model seems to generate predictions that line up with the data. Now, how about quantitatively? So I'm going to show you some aggregate statistics, both in the model and the data, to assess its fit. So first, the model is estimated to target and targeting the aggregate unemployment rate in the economy. So it's not particularly impressive that it can match it. What is a bit more interesting is that it can generate close to the right amount of dispersion in local unemployment rates. The standard deviation is 2.3 percentage points in the data against 2.2 percentage points in the model. And that's in large part due to the fact that the model attributes 85% of that variation to the job losing rate against 86% in the data. Now remember that this is not mechanical because the location decision of employers is left largely unrestricted by the estimation strategy. And to maybe convince you further that that's the case, I re-estimate my model under the directed search assumption, which coincides with the planning allocation. And so essentially all of the parameters are the same in that re-estimated model, but the predicted dispersion in local unemployment rates is less than 20% of its value in the baseline economy and in the data. And the contribution of the job losing rate is in fact counterfactually lower than that of the finding rate. And that's because in the planning allocation or the directed search equilibrium, you don't have this extra labor market pooling externality, which in fact magnifies the spatial sorting of employers so much that it generates a lot more dispersion in job losing rates. And so the takeaways here take three forms. First, it's not mechanical that the model can generate enough dispersion in job losing rates and unemployment rates across cities. In fact, quantitatively, this labor market pooling externality is critical in magnifying the sorting of employers across space, and so much that the unemployment gaps across space are 5 times higher in the baseline decentralized equilibrium than in the re-estimated concern efficient allocation. And so this large discrepancy between both is telling us that there's potentially a lot of scope for policy intervention. And so in the fourth and final part of this presentation, I'm going to evaluate the impact of place-based policies with this estimated general equilibrium model. I'm going to benchmark my exercise with the quasi-optimal policy that corrects the labor market pooling externality. It takes the form of a profit subsidy that rises with the local rate of job loss. So firms in Marseille get big corporate tax breaks or subsidies. It's a federally funded policy with a flat earnings tax to abstract from distortionary effects. And this is a pretty big policy that redistributes 5% of GDP. So we should really think of it as a benchmark. It's called quasi-optimal because the economy isn't fully efficient unless you also implement the Hossus condition. But I'm going to abstract from that for now, for today. And then I'm going to contrast this quasi-optimal policy with an example of the French enterprise zone, the zone franche urbaine. So this was rolled out in '96 and then expanded and targets high unemployment areas with large corporate tax breaks. And to keep the exposition simple, I'm going to consider budget equivalent version of that policy, which loads everything on the profit subsidy. And so this was a much smaller policy that redistributes 0.4% of GDP. Okay, so now let's go back to the map of France, which showed these unemployment rates across commuting zones in the data in the decentralized equilibrium of the economy. So remember, the dispersion ranged from 3 to 15% with a standard deviation of 2.3 percentage points. Now let's implement the quasi-optimal policy. So you can see that the dispersion in local unemployment rate drops a lot, which you can see from the fact that this map becomes a lot more uniform. And in fact, it drops by a factor 5, close to the one we've seen in the previous table. Why is that the case? Because now employers in Versailles are facing these much larger corporate taxes, 30%, against employers in Marseille who faces essentially a 0% corporate tax. And so employers, high-quality employers leave Versailles and on net move into Marseille. But of course, the Versailles ones don't move directly to Marseille. The Versailles employers move to Paris. The Paris employers move to Lyon. The Lyon employers move somewhere else, and then someone moves into Marseille. And so on net, everyone moves down a little bit following the optimal policy. Now, because Versailles is losing some of their jobs, in fact, it's not so much the fact that the jobs in Versailles become worse, but they just have fewer jobs. So the job finding rate declines and the unemployment rate increases by 1 percentage point. In Marseille, the influx of the highly productive, highly stable jobs results in a big decline in the job losing rate, so much that the unemployment rate drops by 5 percentage points. And then because it's easier to rematch workers in a more uniform distribution of unemployment, the aggregate unemployment rate declines by 0.5 percentage point. Okay, and then through the lens of the model, you can translate these local and aggregate employment gains into local and aggregate welfare gains. And so here what you see is 2 panels that show the welfare gains under the quasi-optimal policy and then under the enterprise zone program. Cities on the x-axis are ranked by their pre-policy local unemployment rate, and on the y-axis we're seeing welfare gains in consumption equivalent by city. So let's start with the quasi-optimal policy. So you can see that because of this relocation of employers, of high-quality employers towards distressed labor markets, that cities like Marseille that had a high unemployment rate before the policy was implemented gained substantially with welfare gains that can exceed 10 to 20%. And because now cities like Versailles are losing their high-quality jobs, welfare of residents there declines, although by a smaller amount than the gains in Marseille. Now, the enterprise zone program was a lot smaller in scale and scope, and so welfare gains arise mostly in the treated location. And there, welfare gains are a bit more of 5%. Now, through the structure of the model, you can compute how much of these welfare gains are due to reduced scarring effects in these local labor markets. And so what's happening here is because of the drop in the job losing rate and the unemployment rate in these initially high unemployment cities like Marseille, workers are now scarred much less frequently by unemployment and are able to accumulate valuable human capital throughout their life cycle. And you can see that these human capital gains are in fact quite important in magnifying the welfare gains from place-based policies by almost a factor 2 in initially high unemployment labor markets. And under the enterprise zone program, in fact, these human capital gains constitute the majority of the welfare gains from the policy. Now you can then aggregate these local welfare gains into aggregate welfare gains through the structure of the model, and you find that aggregate welfare raises by 5% under the quasi-optimal policy, and by a more modest 0.2% under the enterprise zone program. Now, of course, the enterprise zone program was a lot smaller, and so what you can do is rescale those welfare gains by the amount of GDP that was redistributed by the policy. And in that case, you find that the enterprise zone program was in fact 6 times more efficient per dollar spent than the quasi-optimal policy. Why is that the case? Well, simply because the planning problem is concave in the size of the policy, and because the enterprise zone program is going in the right direction, you get most of the welfare, higher welfare gains per dollar spent close to the laissez-faire, which is the case of the enterprise zone program. And so this final calculation is useful if you think that there's some distortion in cost of taxation, then policymakers would probably want to stay closer to the scale of the enterprise zone program rather than going all the way to the quasi-optimal policy. And on that note, let me now conclude. In this paper, I've shown that the geography of unemployment is driven by differences in the rate at which workers lose their jobs. I've shown that relationship in France and in the US, and proposed an alternative view of spatial unemployment gaps that emphasizes the key role of employer heterogeneity across space. I've also argued that labor market frictions distort the location decision of employers in systematic ways with important implications for place-based policies. First, they imply that relocating marginally more productive employers with marginally more stable jobs towards higher unemployment labor markets is welfare improving in the aggregate, and quantitatively, I find sizable employment and welfare gains from such enterprise zone programs. But now, of course, these policy implications go beyond the spatial context alone, and in fact, they would apply in any situation in which heterogeneous employers are choosing between frictional segmented markets. You could think of it as employers choosing from different skills or different occupations. And you could also think of it in the context of supply chains and situations in which firms are choosing between frictional input or output markets. And I believe there's a lot of interesting work to be done in this direction as well. And with that, I'd like to thank you very much for your attention and happy to take some more questions.
Great, thank you very much for that terrific presentation, Adrien. We need to stick to our 1:15, so we'll just ask the question which has the most number of upvotes, but thank you very much everyone for the terrific range of questions here. And to reiterate, Adrien will receive the full list of questions and I'm sure would be very happy to follow up by email, but I will turn back to Cecile Gobert, who's got a question with lots of upvotes here.
All right, so thanks a lot, Adrien. It's a fantastic presentation and great paper. And so I had a last couple of questions. So in France, the social safety net, I think, tends to be flat in nominal terms across cities, right? And so it tends to be higher in real terms in kind of in the low price, low productivity areas. Mm-hmm. So I was wondering how that could interact with your models and your facts, in particular in two dimensions. So first of all, the minimum wage, I would think is more binding. I think we talked about that a long time ago.
Yes, absolutely.
The minimum wage is more binding in low productivity areas. Correct, and so that hurts in a way firms more there. And then the other one is the outside option also, arguably is higher in those low productivity areas. And so I was just wondering if you had thought about how that would interact with what you have with your results, whether it would reinforce or
So no, that's a great and important point. In terms of the outside option, it's not entirely clear whether it would be higher and lower. The mall predicts that it's lower. It's also monotonic. It's also lower in low productivity, high unemployment areas. So that's kind of that's accounted for in the mall. Now, the minimum wage is something that's not in the mall, and it's true that it's presumably so it's set in nominal terms, and it's presumably more binding in these high unemployment areas. Now, we know that any form of wage rigidity, and in the form of a minimum wage or something else, is going to primarily manifest itself in the job creation margin. So we should see more depressed finding rates. If the minimum wage story is important, we should see that showing up first in finding rates, in job finding rates in these high unemployment cities, which again we don't really see in the data. So that's kind of telling us that the minimum wage can be like maybe somewhat important in explaining the kind of the small downward slope of job finding rates, but it can be the primary explanation in a purely empirical sense. And then in terms of the mall, you could add a binding minimum wage. So what that would do essentially, it would flatten out the reservation wage in the lower portion of the geography spectrum. And so that has ambiguous predictions for what we should expect, because it's going to generate because the reservation wage is what's sustaining the sorting of employers. The binding minimum wage at the bottom of the distribution is going to generate mixing there, and so it's going to reduce differences in job losing rate and unemployment rates within the bottom of the distribution where the minimum wage is binding. But that's going to mean that it's going to amplify a spatial inequality between the top and the bottom. So overall inequality may go in terms of job losing rate and unemployment rates may go a priori up and down. But I think that's a very interesting question that I hope to be able to think about in either future iterations or future papers.
Fantastic. With that, I'm afraid we're out of time, but thank you very much indeed again to Adrien for a terrific presentation.
Thank you very much to
everyone for attending and the great questions. We hope to see you all next week.